Hi, in this video today we will learn more about especially degree and linearity of differential equation. We have more difficult differential equation and let's learn some details about degree. Okay, the first equation we will check its order, degree and linearity and the type. So what is the order of this differential equation? What we know about the order? Order is the highest order of derivative. What's the highest order? You know that order is related to d. Here d to the power of 7. That is, this is 7th order. This is 2nd order and this is 4th order. What's the highest order? The highest order here 7 and the order is 7. What is degree? We know that degree is the power of highest order. Highest order here, the power here 1. That's why degree is 1. And don't forget, always we are talking about degree, but in mathematics, degree is integer number. Why? Because think about polynomial. Polynomial, when we mention about polynomial, all powers must be positive integer number. That's why degree must be integer number for us, positive integer numbers. That is, to mention about degree, the differential equation as derivative, according to derivative, must be in polynomial form. Must be in polynomial form. What's the polynomial form? That is, all power for derivative, all power of derivative must be positive integer number. If it is not integer number, you cannot mention about degree. Degree cannot be defined. To define degree, the equation according to derivative must be in polynomial form. Okay, this is important. According to derivative, in polynomial form. Okay, according to derivative. And here degree is 1. This is linear or not? What's linear? Linear, if we think linear format, always the derivative in polynomial form. That is the sum of derivative. Sum of derivative, something like that. You cannot see any multiplication of two derivative in linear form. So here we have two derivative in multiplication form. You cannot mention about linearity for this type property. That's why, because of multiplication of two derivative, this is not linear. Be careful, this is extra information for us. And what's the type? We know that if we have derivative of a variable with respect to single variable, here with respect to x, this is ordinary differential equation. And the second one, what we say, if you want to mention about degree, the equation must be in polynomial form according to, with respect to derivative. Here, square root, we know that to the power of 1 over 2, this is not polynomial. That's why let's take square root of both of sides. It will be d4 ds for squared and d cube r dt. This is dt cubed plus 2. Now we can talk about degree because this is in polynomial form. We know that what's polynomial? Polynomial x to the power of 4, x cubed, x squared, x to the power of 5, something like that. So what we say with respect to derivative, it must be in polynomial form, means all power of derivative must be positive integer number. So let's talk about degree and order. Highest order, this is 4, the order here 3. Okay, and the highest order here 4. What's degree? The power of highest order is 2, so degree is 2. This is important. For example, in this question, you say, sir, the highest power, highest order 4, and its degree in the beginning of the question, its power is 1, and that's why degree is 1. No, this is wrong. All of derivative must be in polynomial form okay, and then we can talk about degree. This is important. So this is ordinary or partial. R with respect to x, s and t, that is we have two independent variable. That's why this is partial. And this is linear or not? No, this is not linear. Why? Because the power of derivative is not 1. What we know about linearity, all power of derivatives must be 1. Here the power of derivative is 2. This is not linear. This is important. Another question. What's the highest order? Here 3 and 1. That's why order is 3. So what about degree? What we say with respect to derivative, the differential equation must be in polynomial form. In polynomial form, what's the polynomial form? X to the power of 4, x cubed, x squared, something like that. There is no sign, there is no logarithmic function, there is no exponential in polynomial form. Here with respect to derivative, let's think about instead of x, derivative. So this is like x sine, think about x. It would be sine x. If we have sine x, it is polynomial? No, this is not polynomial. With respect to derivative, sine dy over dx is not polynomial. So if it is not polynomial, we cannot mention about degree. So for this question, degree is not defined because with respect to polynomial, with respect to derivative, this is not in polynomial form. This is linear or not, and this is not linear as well. There is sine, and this is not linear because linear we know that's sum of derivative according to descending order or ascending order, something like that. So this is not linear. And let's talk about the type of differential equation with respect to x. With respect to x, that's why this is ordinary. So this is so important. Polynomial form with respect to derivative, and let's check this question. Polynomial form with respect to derivative. So is it necessary for this question take square for both of sides to remove square root? Is it necessary? No. Why? We are saying with respect to derivative, it must be in polynomial form. In the square root, are there any derivative? No. So for us, there is no problem to mention about degree. If we have derivative in this square, of course, we must take square of both of sides. But here, with respect to derivative, there is no problem for us. So no need to take square to remove square root. This is important because it must be polynomial in polynomial form with respect to derivatives. So here let's talk. What's order? Order is 1. The power of order part is 1. That's why degree is 1. So this is linear or not? This is linear. Why? Why it is linear? There is derivative here and power is 1. In the coefficient there is no dependent variable. There is no dependent variable. And the last thing, what's dependent variable? Y. Dependent with respect to y. There is no another type function. That's why there is no problem. Here in the square root x. X is independent variable. That's why there is no problem for us. But if it would y, let's say 4y plus 5, it will be not linear because the power of y will be 1 over 2, something like that. So this is not linear because what we say, it must be just y, not y square, y to the power of 1 over 2, 1 over 3, something like that. But this is independent variable. That's why no problem for us. There is no problem for dependent variable, that is y. So all properties satisfied for linearity. This is linear. And just we have with respect to x, derivative with respect to x. That's why this is ordinary. We talk about some difficult differential equation on how we define degree and about the linearity. They are so important to improve your knowledge about the degree.